Concept of line charge, sheet charge and volume charge. Welcome back to my channel, myself Basavaraj Hebbar. Next is line charge. Line charge is a concept of electromagnetism where charge is distributed along a line in space. It is represented by the charge per unit length lambda measured in coulomb per meter. Line charge are commonly found in situ- situations like charged wires or cables. Sheet charge refers to distribution of charges over the surface or sheet in space. It is represented by the charge per unit area measured in coulombs per square meter. Sheet charge can be found on conductive surface in insulating materials. Volume charge. Volume charge is the distribution of charges throughout a three-dimensional volume in space. It is represented by the charge per unit volume P, measured in coulombs per cubic meter. Volume charge per percent in material or subjects with a uniform charge distribution. Line charges produce an electric field that points radially away or towards the line charge depending on its sign. The electric field produced by a line charge decreases as 1 by r, where r is the distance for the line charge. The electric field intensity at the point due to a line charge can be calculated using Coulomb's law. Sheet charges create an electric field that is perpendicular to the surface of the sheet charge. The electric field strength due to a sheet charge is constant and does not vary with the distance from the sheet. The electric field intensity at the point due to a sheet charge can be calculated using Gauss law. Volume charges. Volume charges generate an electric field that points radially away or towards the volume charge depending on its sign. The electric field produced by a volume charge decreases as 1 by r square, where r is distance from the volume charge. The electric field intensity at a point due to a volume charge can be calculated using the principle of superposition. Line charges are commonly encountered in scenarios like transmission lines, antennas, and charged cables. Sheet charges are often found in situation involves charged plates, capacitors, and dielectric materials. Volume charges are prevalent in objects like charged spheres, charged volumes, and charged materials. Line charges are typically represented using the one-dimensional delta function in mathematical formulation. Sheet charges are commonly represented using two-dimensional delta functions x and y or distribution like a Heaviside step functions. Volume charges are mathematically represented using three-dimensional delta functions x, y, z or charge density functions. Line charges have a linear charge density that can positive or negative depends on the direction of charge flow. Sheet charge have a surface charge density that determines the amount of charge distribution per unit area. Volume charge have a volume charge density that indicates the charge distribution per unit volume. Line charges exhibit cylindrical symmetric in their electric field distribution around the line charge. Sheet charges display planar symmetric in their electric field distribution perpendicular to the charge surface. Volume charges demonstrate spherical symmetry in their electric field distribution around the volume charge. Line charges can be visualized as an infinite line of charge extending in one dimension. Sheet charges can be visualized as an infinite plane of charge extending in to the two dimensions. Volume charge can be visualized as a solid object filled with a charge extending in three dimensions. Line charges play a crucial role in understanding electric field around transmission line and antennas. Sheet charges are essential in study of electric field capacitors and behavior of dielectric materials. Volume charges are fundamental in analyzing the electric field within charged objects and materials. Line charges follows the principle of superposition, where the total electric field is the sum of field due to an individual segment of line charge. Sheet charges obey the principle of superposition, where the total electric field is the sum of electric field due to the individual point on the source surface. Volume charges adhere to the principle of superposition, where the total electric field is the sum of the field due to the individual elements of the volume charge. Line charges are commonly used in theoretical models in simplifying complex charges distribution. Sheet charges are employed in practical applications like the design of capacitors and charge store devices. Volume charges are essential in understanding the behavior of charged materials and objects in conclusion. Line charges, sheet charges, and volume charges are the fundamental concepts in electromagnetism that helps describe and analyze charge distribution in various scenarios. Understanding the properties and behavior of line charge, sheet charge, and volume charges is essential for application in physics, engineering, and technology. The concept of line charge, sheet charge, and volume charges provides a comprehensive framework for studying electrostatics and charge interactions in three dimensions. Thank you.